record now. So let's see. So it's here now. All right, so that's good. Yeah, just hold on there a minute, please. Hold on there a minute. Hi, Shelley. How are you doing? You did.
Are you down in Andrews today, Kieran?
No, I'm at home because I'm trying to keep an eye on the kids, get them to do something. But it's
you're
hard.
up and running with your own machine, so
Yeah, just about not perfect, but I know I'm following fine on the computer. Just bits and pieces I need to.
Is Andrew on?
He was on earlier, but he was having a problem with the sound. I'm not sure. I can't see 100% here now, but he was on earlier this morning. But I think his sound wasn't great. But I think he probably is.
And is the internet bad in his house or what?
No, it worked fine the last day. But it's something to do with sound. No, like it was on when we were in his house last day. We were using my computer, but he might be using his own, and there might be some sound issue. I don't know.
Oh, right, okay.
But I think Igor was saying there, if you go into Zoom itself, you can adjust the sound settings or something like that.
Yeah.
And that might work. How are things on with yourself?
Good. I just after a lovely chicken and leek soup that I made.
Genie Mac.
Yeah.
So you're all full of energy now, ready for the session.
Oh, fucking bananas! Like, yeah.
I suppose bananas for monkeys.
I find it hard to contain myself here. I'm so revved up for it, you know.
Yeah.
I tell you, that woman will be missing you in the canteen. That's for sure.
I'm sure she is. But yeah, sure. We're going to get back there again now. No?
I don't know. Sure. We're not letting into the place now.
I'm hearing a lot of coughing there. I hope everybody's coughing into their elbows.
Yeah. or coughing into someone else's elbow.
Yeah. It's like Ed. This 30 seconds of quietness was brought to you by Dennis.
Hold on. Sorry. That was just my niece. Bit of family business. Okay, so we will start again, so folks. Priya and Kathy, welcome.
Hello.
So, where are we? Oh, we're going to close the door. Fuck, it's cold. It's cold, but it's now Priya and Kathy, we did something there, so I'll just do it for you as well. Hold on a second. So what we did was, if you just could sit there a minute. What I did for the rest of the class was this. I played some Marvin Gaye. Is that okay?
Yeah, that's fine.
That's for.
It's better than Royal High.
So that's for Kathy and Priya. All the rest of you have it now. So we've all had our daily dose of Marvin Gaye. So now we're ready for Jan. Okay?
Yeah.
All right. So anyway. So we have seen, I'm just looking out the window here. I have seen around 50 cyclists passing here today. Jesus Christ. Nothing else for people to be doing, I suppose. Anyway, so these are streams. So we're dealing with file output streams and file input streams. Okay? Now, file input output streams and file output streams are low level streams for dealing with files. All right? So what you do is you do a read. So we can see here that we have that this loop goes 54 times. Okay, this loop goes 54 times. Why? Because it's reading in 1 byte at a time. Does everyone understand that? Yeah?
Yeah.
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 Okay. So now think about that. So it's reading and it's also writing 54 times. Now, when you're writing to a hard drive is always, doesn't matter what sort of hard drive you have, it's always going to be slower than your RAM. It's always going to be slower than your buffer. All right. So what you have here is 54 writes. Okay. Yes.
Okay. Yeah.
So what has happened here is, so it's 54 times our slow permanent memory hard drive is being accessed. All right. So it doesn't matter what sort of file output stream you use. File output stream is slow. All right. It's slow for the simple reason is that it's accessing your hard drive. Now I have the best hard drive money can buy. All right. I paid a lot for this fucking laptop. All right. Now, even that is way slower than the RAM. All right. So what you always want to do is when you're writing to a file, if you're writing to your hard drive, you're trying to speed it up because this is going to slow. If you're dealing with, let's say if you're dealing with the Bible, there could be a couple of million characters in the Bible. That means your hard drive is being accessed a couple of a million times. All right. So that's going to be slow. Yes?
Yeah.
Yeah. Right. So what we want to do is we want to speed this up. All right. Now we can speed it up via these guys. So we're going to go static void ex2. Now, so what we're going to do is we go these guys. So I'm going to go. I'm going to put a star beside it, and this is buffered input stream. Buffered output stream. Now, the difference between a buffered output stream and a file input, so for instance, buffered input or buffered output stream. Okay, the difference between a buffered output stream and a file output stream is that a file output stream is going to write to our hard drive 1 byte at a time. Now, a buffered output stream, you can determine how many bytes you want to write at any one time. Okay, you can determine, so you can say, I want to write 1,000 or 1 million bytes in one go. Okay, so it's going to access your hard drive only once, and it's going to write a megabyte. All right, or now I think there's a limit. I'll show you what I mean. Okay, so I'm going to create 2 new files. All right, so I'm going to go file, my file is equal to new file, and I'm going to call this source2. And I'm going to go file, my file 2 is equal to new file, destination 2. Okay, and we're going to do, so we're going to have our try catch block. So what's this one? This is the file we read from. This is the file we write to. All right, now, so we have our try catch block. Right, so we're going to say if my file if that guy, my file dot exists, so that means, sorry, exists. So if it doesn't exist, what we're going to do, we're going to create it.
No, should that be in the try catch block?
Oh, geez, yeah, Kieran, you're right. Yeah. Jesus, what am I doing? Thanks, Kieran. Okay. So if my file 2.exists. Oh, Jason, are you there?
I'm here, yeah.
Jason, we just had an idea for an app as well. We might talk to you a bit at the end of class today. Is that okay?
Yeah, brilliant, yeah.
No, but this is an app now that can, it's something that, it's a doctor that actually said it to me. They're looking for something like it.
Right.
So it's something, now it's something that could be developed fairly quickly. If we could develop it in 3 or 4 weeks, even if we have to not do any lessons for a day and try and develop it, it might be worth it, because it's something that's actually needed at this moment in time. It's to do with the coronavirus. It's something simple.
Okay.
Yeah.
Brilliant.
Right, so we'll talk about it in the class today. Okay, so my file dot create new file. Okay, now, so I am going to run this code and go here. So examples are ex1. Oops, sorry. Right, so I ran that code, I click on refresh, and there we have source 2 and destination 2. Okay, now I want to go to destination 2, and I want to type the following. So, following, we're going to type it, or not destination 2, sorry, source 2. So I'll close destination and source, and I'll open up source 2. And I want to write Humpty Dumpty sat on a wall. Humpty Dumpty had a great fall. All the king's horses, all the king's men couldn't put Humpty together again. Now, we're not counting or anything like this. We're just going to be taking in this file, and we're going to be writing all of that text into destination 2. That's all we're going to be doing. Now, however, this time we are going to be I'll just put in here. So what does this do? This creates our files. Right. So what we're going to do is we are going to create a buffered input stream. Okay? So now we usually have, as I said already up here, is that when we're using a particular object for inputting and outputting data, we usually have an abstract class reference on the left-hand side. Okay, so these are streams, so we're going to have an abstract reference. Now there is a reason, I can't remember the reason why we do it. I'm sure we'll encounter it when we're doing the questions. Okay, so input stream, in. Now, so this is an abstract superclass reference to a concrete subclass. Now, this is going to be new buffered input stream. Okay, now, what does this do? This takes so I still need some sort of object that takes in 1 byte at a time, right? So I'm going to go file, input, stream, And what we're gonna get it from source2.txt, which is my file. All right. So I need to import it. So what is this? This is what we're going to use to read in our text. Right. Now, and we're going to output it. So we're going to have an output string. Out is equal to new buffered output stream, and then we're going to go new file output stream. It's going to be my file 2. Put it here. So this is the object we will use to write to the file destination 2. This is now to use all our text in the file source 2. Right. Okay. Now, so what a buffered input and buffered output stream means, okay? It's going to read X amount of
Even
bytes.
just sticking there from the last day, skewers, so use the mum said.
Okay.
They're in there.
Here.
Sorry.
No, it's all right. We just said we can hear you, so don't say anything private.
All right.
No, I don't mind. I'm not giving out.
No, that's right.
Okay. So, geez, my hair is getting woefully long. Buffered input stream. Now, what a buffered input stream means is it's going to read in an amount of bytes. Now, we're going to tell us how many in one go. Instead of reading in 1 byte at a time, it's going to read in X amount of bytes. Now, how many amount of bytes is it going to read in at a time? So I go byte buffer is equal to new byte. Now I'm going to give it 1024. Okay, 1924 bytes, which is, what is that? Can anyone tell me what's that? What's that otherwise known as?
Kilobyte.
It's a what?
Kilobyte.
Kilobyte.
Okay.
Yeah.
This is 1 kilobyte of data, right? So what we're saying here is we will read and write in blocks of 1 kilobyte. All right. So if you have a file that's going to be 10, or that's going to be 1 megabyte, all right. If you have a file that is 1 megabyte, you're going to have 1,000 reads. Yes.
Mm-hmm.
Yeah. So if your file is 1 megabyte, you will have 1,000 reads, as there is 1,000 kilobytes in 1,000 kilobytes in a megabyte. Now, if we were using file input stream, then we would have 1,000,000 reads instead of 1,000. Okay, so by doing something as simple as this, Instead of reading, so what you'd have, it's going to read 1,000,000 times. Then it has to write 1,000,000 times. All right. So it's now reading as well as accessing the hard drive, because your file is kept in the hard drive. So it's not your RAM. But writing is writing 1,000,000 times. As opposed to this will only write 1,000 times. Now you can change that to 2 kilobytes, 10 kilobytes. Now, I think once you go above a certain number, any gains, it depends on how much RAM you have and all sorts of things. But we're going to start off with the kilobyte. All right? So we're going to start off with the kilobyte. Now, so I'm going to put in something here called int length read. Now I'll explain that in a minute what it is. Okay. Now int counter is equal to 0. All right. So what is counter? This will count how many times our while loop executes. So we'll count how many reads and writes to the hard drive, or sorry, to main memory, which is the hard drive.
No, sorry, can I ask a question there? Just
Yeah.
why, if you're using file input stream, do you get 1,000,000 reads rather than 1,000? I don't understand that.
Right. So if you're using file input stream, right? So it has to do it for every byte. It reads a byte, it writes a byte, right? So if you've got 1,000,000 bytes, it has to read 1,000,000 times. It has to write 1,000,000 times. Get me?
Yeah.
Because it's doing it one at a time. So we'll concentrate on the writing. Okay. So
one question.
Yeah,
one question though.
I'll answer Iggy's question first.
Okay, sorry. I'm sorry.
Yeah. So I have a file that's 1 megabyte. Right. So I want to write to a file, and at the end of that file, the file is going to be 1 megabyte in size. All right. Now, if you use file output stream, that's going to, so how is the all the text in that 1 megabyte file written? All right. It's written 1 byte at a time. All right. So it writes so it accesses the hard drive, writes. Then it accesses again the hard drive. So let's say Humpty Dumpty. Okay. If I'm writing this to another file, it's going to have a write operation for H, a separate write operation for U, a separate write operation for pt3. You've got 1,000,000 bytes in your file. If you're using file input stream, you're going to have 1,000,000 different writes. Okay. As opposed, if you're writing 1,000 bytes at a time, say 1,000 characters, all right, you only have a write after 1,000 characters. So in this case here, I have set my thing called a buffer. So what does it do? The first 1,924 characters, they're going to be written to our file all in one go. Then the next 1,924 characters. Okay. Now, so we'll change that. We'll just say there's 1,000. There's 1,000 bytes there. There's 1,000,000. So there's 1,000 there, and there's 1,000 kilobytes in the megabyte. So there's 1,000 of those in the megabyte. So if there's 1,000 of those in a megabyte, that means to write to a file, and it's going to be 1 megabyte in size, that means you only have to do 1,000 writes. Does that explain it, Iggy?
Yeah, so is that for a file input stream, is there a default of 1,000,000 bytes?
No.
No.
There's no default. Right, well,
So-
what I've done, yeah, I'm going to be doing a loop now, right? And what the loop is going to do is it's only going to read in, or it's going to write 1,000 megabytes at a time. So it'll write in 1,000 megabytes, and we have a counter going along that counts up all the bytes. So only when it gets to the next 1,000 bytes will it do a write again. Okay, because what's actually happening then is that it's writing all of those bytes to a buffer. That's the size of the buffer. So a buffer is just a temporary part of your memory. All right. So your buffer stores 1,024 bytes. Okay. So it stores. So it counts up the characters. When it gets to 1,024 bytes, it's only at that point does it write them to the file. So it's writing 1,000 characters at a time instead of writing one character at a time. So it only has to call write once for every 1,000 as opposed to write every byte. Does that understand? Does that?
Yeah.
Okay.
Yeah.
Now, Kieran, what was your question?
I suppose my question, Noel, was, you know the file input stream, that reads 1 byte at a time, right?
Yeah.
And the buffered input stream can read big chunks of bytes at a time. But the buffered input stream is reliant on the file input stream. So sometimes you kind of, because that's got through the file input stream anyway, you kind of see how's the gain happen, because it has to use the file input stream.
See, how the gain is going to happen is that this guy here is being read into the buffer, which is extremely fast.
Oh, yeah.
Get me?
Yeah.
So it reads in, it's going to be reading in 1,000 bytes at a time. So those 1,000 bytes are just flying across.
Okay, yeah. Okay, fair enough. Yeah, I get.
Okay, so that's where the savings is actually are, because you're dealing with the buffer, you're dealing with the RAM, you're not dealing with the main memory.
Yeah.
Okay.
Okay, yeah. Okay.
So now, right. So I have a counter. Now I'll explain what length read is after I do a little bit of code. Okay. So this is the amount of bytes we want to read. So when it gets to that point, it's going to write 1,000 bytes into our file at a time. All right. So I'm just going to do it here first. So while. Now, so I put in another one here. Let's say length is equal to in dot read. And there is a constructor that takes this guy. Okay. Greater 0. And it is length read. Now, so I'm just going to do all the rest of the code for a minute. I want to count how many times that is run. I'm going to write it. We start off with buffer. Then we go to 0. Then we go to H. Yeah. Oops, sorry. Now I have to make sure I have this right. And I'm gonna go out dot flush. Right, now, so I really wish I had my pen to explain this, but I don't have it, so we'll just have to do it. By the way, can everyone see that screen? Do you want me to make the text bigger?
It's fine, I think. I don't know.
Is
It
it
looks
fine?
good.
No, it's okay. Yeah,
Grand?
yeah, grand.
Okay. By the way, just to let you know as well, you can convert your television into a second screen. You don't need a cable, just for yourselves if you want to do that.
I try to open the same screen in Eclipse and the Zoom. No, I can't work it. So
All right. Yeah.
yeah.
We won't bother, so great. Take it. Okay. Anyway, right. So
I think you need a password as well, the operator. Like for my Skybox, to cast it onto the telly, it's my partner is paying the bill and he won't give me the password.
yeah, well, I think the way it goes, Kathy, is you have to go to the television's menu to screencast, not the Skybox. You won't be able to cast in the Skybox, so you'll have to go to the television. You know the controls you have for the television?
Okay.
Yeah, so that's the way you do it. Okay?
Okay.
Yeah. But anyway, that's neither
But
here nor there.
I don't think it's modern enough.
Well, it has to be smart television.
It has to be smart. Oh, right. I don't think it is.
Yeah, right. But anyway, we can make do with one screen for now. Okay. So now this method here, in.read. Okay, in.read can also take arguments. All right. Now, one of the arguments it can take is an array of bytes. Okay, so it takes in an array of bytes. Now, what happens to in.read when you take in an array of bytes is it starts to read in all of the data. Okay, so linked read starts off at 1024. Okay, so linked read starts off at 1024, and as everything is added in, as files are read, that 1024 clicks down. Okay? So this will keep on going on to 1024, or alternatively, if it gets to the end of the file. If it gets to the end of the file, in.read also reads. If you get to the end of the file, in.read reads -1. Okay? So in.read, when it takes a character, all right, it keeps on reading all of the bytes until it gets to 0, or until it gets to -1, which is before, same as before. So in.read still returns a number. Okay, now at the start, let me just have a look, see here. Okay, right, let me just see, has it worked? It has worked. All right. All right, take that out. Now, so link.read, in.read returns an int. Okay, it returns an int. If it returns -1, that means it's greater than the 5. That's why I have 0. Now, also, in.read, there is an overloaded method that takes an array of bytes. Okay, and so that array of bytes is set to size 1024. So this loop will stop if it gets to 1024, or if it gets to -1. All right, now what happens inside it? What happens inside it? I have a counter here. I'm just going to go outside the counter. All right, so this, so out dot write buffer. Okay, so it's going to write at a time a maximum of 1024. Okay, it's going to write at a maximum of 1024 bytes at a time. Okay, so it's going to start at, so let's put this here now. So it's going to start here. So that's the maximum size it can take. All right. It starts at position 0. Now, position 0 is relative. What do I mean by relative? So the first 1024 characters is going to start at position 0. The second block of 1024 bytes is going to start actually at position 1025, but it's relative. It's the first element of the next block. Do we understand that? Yes?
Yes.
Yeah.
Okay. Now, length read. Length read is the actual amount of bytes that's written to it. Okay. Now, sometimes if your file is bigger than 1024 bytes, then the first time your buffer size and your length read size are going to be the same size. All right. In this case, we only have 139 bytes in the file. Okay, there's only 139 bytes in the file. 139 bytes is a combination of all of those characters, backspaces. We also have apostrophes. We also have a new line breaks, whatever. Okay, so what's the size of the file? This file has 139 bytes. Okay, so the length read is the amount of bytes that are actually in the file. Okay, what is this? This loop will only execute once in our case. Okay, this loop will execute only once in our case. So instead of executing 139 times, it's actually, so instead of having to write 139 times, it only has to write once. Okay, and I flush it. This is to make sure the file is written to. All right, so the whole idea of this is to make sure you're not accessing the hard drive excessive. Now, do you ever hear sometimes your hard drive, it starts, the older ones, you'd hear this clonking sound? Yeah?
Mm-hmm.
All right, so that is when you're reading, or more particularly, when you're writing. So a badly written piece of software, actually, if you load up any old software in your, if you haven't the older hard drives, if you load up older software in it, you will almost certainly hear them going this, this noise. Why? Because it's reading every byte as opposed to reading blocks of bytes. So let's say if you have something that's 100 megabytes in size, you could have 100 million writes going on there. That's why you have that sound. All right. So badly written software does make a difference. So this guy here, it's all, you only have one write. As opposed to 139 writes if using file okay, so you only have one write as opposed to 139 writes if using 5 input stream. Okay, so can you see the advantages of using buffered input streams as opposed to file input streams, in that they're much faster? Any questions on that?
No, the lint.read will give you the last amount that was written to the so if there's 5 goals, it'll give you the last amount in the last one, yeah?
But no, it basically counts the amount of bytes in the file. All right?
Yeah.
So I am going to do a couple more.
You don't get that, please. Sorry.
I suppose you're going on to the next point. If greater than 2,000 bytes in the file,
Well, you see,
then it will reset at 1,025 to do the next block.
so
Or restart.
so here's the thing, right? In that read, what I'm going to do is I'm going to open up a Word file here, right? So a Word file that has loads of words in it, and I'm going to put it into a text file, all right? And we'll see. So there'll be more than bytes in it. So just give me a second here. So just hold on a second here. Now I will load up the questions file from Java 1. Oh, fuck. Hold on a second. Wrong one. So just give me a second here. So next. All right, so I am going to load up this guy. So, no, not that one. I don't want that one. So give me a second again now. That's the one that I'd opened. I'll open change questions. Instances. Open. Question 2019. Right. So now, so I am going to go. So here it is. I don't know. Right. Fucking hell. All right. Now, that's a huge file. All right. That is, just to bring it back to you. Remember these guys? Remember the Java 1 quiz? Those that did Java 1? Remember them guys? God be with the days. Happy days. No.
Happy times. No.
Oh,
Happy
great times, great times. Now, it won't say, let me see, file S. Yes. Okay, right. Now, so, now we'll attempt to read this and see what happens. All right? Right. So there we have. The loop only executed 499 times, which means that this file is, so that's we'll say 500 kilobytes. This file is a half a megabyte in size. Okay, it's reading, Jesus. See what it's reading? So 1024, let's go back to it here. Where are we?
Okay.
Right, so it's not this file, this block of code has X amount of bytes. All right, so see what it's doing? It's reading it in blocks of 1024 bytes. See it? This block of code has X amounts of bytes. The maximum amount of bytes it can read has been set to 1024. Now, if I change it to, now you're better off to save it in, so 10 kilobytes would be 10,240 kilobytes. So instead of getting us 499 reads, we should get 50 reads. Okay. You can change that buffer to be any size you want it to be. Now, I think if you make the buffer, now, don't make the buffer too big. The reason you don't make the buffer too big, because it's relying on the RAM of whatever machine you're running on. All right. If you make the buffer too big, then it can quickly use up all of the RAM. Now, most machines have got a couple of gigabytes of RAM. So you should be able to increase this, let's say, to that 102400. Now that is a megabyte. It's not a megabyte. That is a, how many kilobytes is that? That's 102 kilobytes. Okay, so that's 102 kilobytes. So that means that this guy is a megabyte. Does everyone understand what I've done there?
Mm-hmm.
Okay, so all a buffer is, we're saying we're going to write a megabyte at a time. We're going to write a kilobyte at a time. We're going to write, so I'll just put it in here. So this is 1 kilobyte of data. Okay, I'll do all the other versions down here. So I can say this is 10 kilobytes of data. This one here, you just add a 0 onto it. This is going to be 100 kilobytes of data. Okay, this one here is going to be
Megabyte.
that's a megabyte of data. So 1 megabyte. Now I think actually you can, I think you can do a read of 1 terabyte or 1 write of 1 terabyte. I think that's the maximum. It used to be 2 gigabytes, but I think that's changed to 1 terabyte now. I don't know what the limits are. All right. For now, I'd advise you to stick with just 1 kilobyte. And you can experiment with different, 10 kilobytes of data should be fine as well. 100 kilobytes of data is probably going to be fine as well. 1 megabyte of data probably should be okay for most systems. But remember, you might be designing just for Android, you might be designing for watches. You might be designing for a program that's going to put on a chip. All right. So the buffer totally depends on what you're developing for. Does everyone understand that? Yes? Yeah? Any questions? No questions?
That's grand, yeah.
Okay, all right. Right, so now, believe it or not, that's all there is to file input streams and buffered input streams. That's it. All right. I won't necessarily say they're easy, but there isn't an awful lot. That's basically them. All right. It's really only 2 types: file input stream and buffered input stream. Now, remember, buffered input stream and buffered output stream. It's not for about dealing with characters. It's for dealing with bytes, and it deals in groups of bytes. And in this case, it deals in bytes of 1024 or less. All right. And this program here contains all of this shit. And there it is, all written to here. Okay. So if I change it to 1024, we'll see that it's been executed 499 times. Now I'll leave that file there. So this executes 499 in this case. Okay, this loop will execute 499 times, as opposed to because this file is 0.5 megabit in size. So you only have 499 writes as opposed to 500,000 writes. So it's nearly always a good idea to make sure that you're writing to the hard drive as little as possible. All right. Now, the one caveat with buffered input streams and buffered output streams is that you're more likely to get an error. More than likely. So if you are going to get errors, so if your files are small, all right, then file input streams, file output streams are fine for them. Okay. If your files are big, obviously buffered output streams are better, but there is a chance that errors could be introduced. All right, there's more of a chance that errors can be reduced than in file output stream. All right, so you have to weigh up the pluses and minuses, but generally buffered output streams are far better than file output streams, far quicker. Any questions on that? No?
No, just the value of length read in that case is 756. It'll be the last one, will it be?
Yeah.
At the end of it?
Yeah.
Okay.
Okay.
All right, yeah.
So, because you can see here, it starts off as, so length read. So let me go down here. So, it's going to be 1024, right? Keeps going 1024 because what it does is, so it's maximum size of 1024. Okay, so it can read in 1024 bytes, but this has 500,000 bytes.
Yeah, yeah.
Right? So it reads in your 500,000 byte file in chunks of 1,000 bytes. That's all it's doing. Okay, and we'll see what the last one is. So 656. That's the amount of bytes in the last chunk it's going to use.
That's okay. And it'll be the last value of length read will be the last amount that's in the last chunk, yeah?
Yeah.
Okay. Okay.
Now, if I did put a flush in there, let me just see what happens. Okay. Right, so you'd really, now, you can put a flush, or you can put in an out.close. Now, the reason I'm putting in an out.close is there's a lot of stuff happening with the buffers, right? So stuff might not be written to. So it's more important to close a resource than you would with, let's say, a file input stream, by virtue of the fact you're dealing with more stuff. All right, there's more chance that errors could happen. All right, so out.close is probably what you'd use instead of out.flush. All right.
As good practice, should you not be doing that anyway, Noel? Should you not be putting in a close there?
Yeah, but you don't put the close. Here's the thing. You don't put the close in here. Right? That'll only run twice. Because what happens is it goes through the loop. Now, it's actually only running once. It's saying that it's running twice, but it's not. It's running once. What happens is during the first iteration of the loop, first thing that happens, it closes. So it never goes into the next block of code. Okay, so if you are going to use, you can use flush inside here, but you can't use close inside here.
So you put it outside. You put it outside that while loop, basically.
Yeah. Okay, but as you said, again, it is good practice to always close your resources. And funny, so does everyone understand that? So all that's happened with the buffer is you have a chunk of code, you have a chunk of bytes in your fast memory, held there. Okay, it's held there in your fast part memory, and it's good. So you have 1,000 bytes. So writes in 1,000 bytes at a time, as opposed to a file input stream which writes in 1 byte at a time. So if you have 1,000, if you have 1 megabyte, if you're using, and your buffer is set to 1,000 bytes, you're going to have 1,000 writes. If you have a file input stream, that means you're going to have a write for every byte. That for a 1 megabyte file, you are going to have 1,000,000 writes. So it's 1,000 times less writes to your hard drive. And you want to avoid too many writes to your hard drive, not because there's anything wrong with it, because it's slow. Simple as that. So any questions on that? No questions?
No.
No. Nope. Okay. Now, so I am going now. Speaking of closing resources, so we should always close resources, but it's easy to forget. And also, if you don't close your resources, you're not guaranteed that your stuff is going to be written to your file. So, what we're going to show you now, static void ex3. Okay. Now, this is try with resources, closing file, closing input output resources. All right. Now, so I am going to do the same thing here. Okay. So I'm going to go file. My file is equal to new file. I'm going to say source2.txt, and then we go file, my file 2 is equal to new file, source, or sorry, destination 2.txt. Now, so if we want to automatically close our, so let's say we're going to have an input stream and an output stream. Now, if I do this, try, and I remember this guy, this is a try with resources. Now, when I said before, try with resources, it allows you to close the resources automatically. At the time, we didn't really know what resources was because we hadn't used any. Now, a resource is something that's external to your file or external to your code. Now, so file output stream and file input stream are both resources because they're dealing with something that's external to your code. So when you have a try with resource, so here's the try with resources. All right, now I am going to go input stream in is equal to new buffered input stream new file input stream my file. Okay. Now, when you have a try with resources, each resource has to be separated by a semicolon. Okay, so we have another semicolon.
You mean views on, is it?
Yeah.
Where?
With me and
Should I then next time?
And we have to put that guy there. Now, so here we have, so just to clearly show you. So this is the tribal resources. Now, so what you do is when you create the resources inside your, it's here. So when you create the resources, inside a try with resources parameter list. So it's these brackets after a try block. An ordinary try block doesn't have a parameter list. Okay, so I'll put in here an ordinary try block or any try block Java 8 did not have a parameter list. Okay, when you create the resources inside a try with resources parameter list, their resources are automatically closed at the end of the try block. All right, so they're only live while they're inside the try, and as soon as you're outside the try, so put in here the input stream in object and the output stream, sorry, buffered input stream the buffered input stream object in and the buffered output stream object are only available inside the try block and are closed automatically at the end of the try block. So we don't have to go in.close or out.close. Okay, so we don't have to do that. Both of those are automatically called at the end of the try block. Because you've created them inside here. All right, you've created them inside here. That means they're only available inside the try block anyway. But when you create them inside here, that means now it's this part we're worried about. Okay, that's what we're talking about. So when it's created there, and it's created there, it's only available inside the try block, and also at the end of the try block, they're automatically closed. Okay, is that okay with everyone?
Yeah.
Okay, so try resources are brilliant. Now you could also create them. You can create the reference outside the try block. Okay, so you can create the reference outside the try block. All right. I think. Now, hold on, what have I done wrong there? Let me just see. Try that for a second. Okay. Maybe you do have to do input stream. Maybe you do. Yeah, it looks like you do have to create the references as well.
No,
Uh,
I don't know when you've got within the 5 block, you've got input stream in. Is it because you've got input stream in front of the in the 5 block? If you took the input stream there out, would that do it?
yeah, oh yeah, we'll have to take those out, yeah.
No, but say if you left it in up there.
Oh
but
yeah, yeah, I took it out, yeah, hold on,
Yeah.
yeah. So, yeah, that's what's wrong. Okay, so I should be able to go, yeah, that's what's wrong. Hold on. No. So,
Take out the input stream there now, it should work maybe.
yeah, it should work. I'm not guaranteeing that it does.
Yeah.
Yeah.
Oh, that's good.
No. No, it
No.
doesn't. No, it doesn't, because look at here.
Oh, yeah.
So, you, I thought you could do that. Apparently you can't. Okay. So, apparently you can't. So,
I guess that makes sense because then you have access outside of the try, then, don't you?
well, but you see, you can create an input stream or a file input stream object outside of a try block anyway. You can have
No.
an,
Sorry, go on.
right, you can't, right, so you can't do this. So let me just put this in here. So, I'll comment out these two guys. All right, you can create a file input stream object, an input stream, or anything that extends the input stream object. So let's just say input stream, and I call it into. So you can create a reference, right? But you can't actually create an object outside of a try block. Okay, anything to do with the file. Now, anytime you're accessing a file, the file may or may not be there. So that's why it has to be in a try catch block. All right. So if you're creating an object to access the file, to read it or to write it, that has to be in a try catch block. Okay. So you can have a input stream reference, no problem. All right. So that you can do. All right. But you can't create an actual object. So buffered input stream, file input stream, you can't create that outside of a try catch block. Is that okay? Yes? Is that okay?
Yep.
Yes.
Okay. Right, now.
Sorry, no. Sorry, does the exception there below the try, will that catch the specific stream that has the exception, will it?
Yeah.
It will.
It will, yeah.
So it is available in the catch as well as the try.
Oh, it is, yeah.
Streams,
but,
yeah.
Yeah, this is available. But with the try resource is basically when it's finished, well, so if an exception is generated, so if this file doesn't exist, the object is never created either. So it doesn't need to close it. Get me?
Yep.
No, because this guy here, if we can't access source2.txt, that means that this object is never created. If this object is never created, that means the exception is generated. But that also means we never have to close it. So if the object is not created, we don't have to close it. Makes sense. Is that okay?
Yep.
Okay. Right. Now, we do come back to these tribal resources. This is kind of just more of a kind of an introduction to tribal resources. All right. They're very useful. They're much more useful than having a try and a catch or having using close. All right. Now, so that is file input streams. All right. So the next type of one. So I need to split these up into. So this is going to be 8.3b. Okay. So it's 8.3b working. 8.3b working with streams. Okay, it's still 8.3, but we've other files that we want to be dealing with. So this is 8.3b. So I'll go here, new Java project. So it's going to be F, and this is going to be 8.3b, working with streams. Finish. Okay. And I'll export that code. All right. So I'm still recording, but this is still 8.3. All right. Now, so 8.3b, so I'll close it off here in my other file. So if we're doing bytes, the next one is obviously going to be dealing with characters. Okay. So it's only go to our package, Combat Android. Oops, wrong one. And new package, new class, main, public satisfied main, new class. All right, and main. So, right, so we're in examples. So this is going to be, so we're going to go to static void ex1. And this is going to be file reader and file writer. Okay. Now, so just like their streams equivalent, they have a read and write methods. Okay. However, these classes work on characters as opposed to byte values. So they also have lower level classes that deal with individual characters and higher level classes that deal with groups of characters. Now those groups can be words, sentences, etc. All right. Now, so we are going to have, let me just have a look here. So we're going to create a text file. Okay, so file. And this is going to be called input.txt. Now, we are going to write the following. Little Miss Muffet sat on a tuffet, whatever that is, eating her Christmas pie. Along came a spider and sat down beside her, frightened let's muff it away. Right, so that's the file we're going to be reading from. Okay, now we are going to create the output file ourselves separately. So this is going to be file, my file is equal to new file, input.txt to import that. And I'm going to go file 2 is equal to new file, and it's going to be output.txt. Now, so what I'm going to do is I am going to create an array list. Okay, I'm going to call this strings is equal to new array list string. Import that guy, import that guy, and I'm going to create another one called list string words equal to new array list. Okay, so we are going to be reading characters, and we're going to be storing these characters in a string temporarily, or in an array list of strings. This is we will use these to store words and strings from our files. Okay, so what we're going to be doing is we're going to be reading in from the input file, and we're going to be reading them into these lists. Okay, now I haven't shown you the way of doing it, right? But that's all these are. These are temporarily stored, and then we're going to be writing them out to an output file. All right. So if the first file doesn't exist, so I need to go try. I'm not going to bother trying resources this time. Catch. All right, so I'm going to go if my file doesn't exist,
I'm going down now.
I call that create new file. Okay, if 2.exists, my file 2.create new file. Now, so I am going to create a, hold on a second now. Hold on a second. Okay, hold on a second now. Right, so I will do a primitive type first. So this is reader. I'm going to call it reader. I think that's the type, isn't it? Import reader. Okay, so reader is equal to new file reader. I'm going to go my file. Okay. File reader. So the next one is writer. Writer is equal to new file writer and my file 2. Okay, so import that guy. Import that guy. Now, I'm not going to actually use these files. I'm just going to say, if we were to use this, okay, so if we were to use these objects, we would have a read from the hard drive, or we would have a write to the hard drive for every character file, as opposed every byte in the file. So 900 characters in a file to be written. We have 900. Okay, so it operates on the same principle as the input streams. Yes? Yeah?
Yep.
So it's reading in 1 byte at a time, it's writing out 1 byte at a time. That means it's accessing the hard drive 1 character at a time, right? So now, what we're really going to use is we're going to use buffered readers, okay? That's what we're really going to use. We're going to use buffered readers. So this is the guy, so put it here. First of all, we create a buffered reader. Okay. Now, so this is going to be buffered reader. I'm going to call this buff read is equal to new buffered reader, and we're going to take in this reader object, so put it in here. Okay, so go here, import buffered reader. So now we have a buffered reader. All right, everyone okay with that so far? Yes? Yeah? Okay, right. Now, I'm not going to put everything into one while loop here. I'm going to put it over 2 while loops just to show you, but you can put it into 1 while loop if you want. I want to put it over 2 while loops to make it a bit more apparent what's happening. Okay? Now, so I am going to go while. Okay, so here we're going to go string s. Now, so string s is going to be either a word or a line. All right, what do I mean by that? All right. Now, string is going to be put equal to Little Miss Muffet. And then that line is going to be read into, it's going to be read and it's going to be written to the file, sat on a tuffet. That S is going to be put equal to that line, and that's going to be written to the other file. This is going to be read in and read, and it's going to be written 1 line. So you're only going to have 1, 2, 3, 4, 5, 6. All right. We're going to have 6 reads and 6 writes. It's reading 1 line at a time. It's writing 1 line at a time. So if you're using buffered readers, what they're really for is for text editing. That's what they're for. Well, yeah, if you want to get any information from a text file, you can use a buffered reader. Whereas the streams, they're all more about data in a file. All right, you're processing 1,000 bytes at a time. It doesn't give a shit what 1,000 bytes they are. All it cares is that it gets to the file. When you're using a buffered reader, it does care about the data. Okay, it's processing it one line at a time. So it's going to process 1, 2, 3, 4, 5, 6, as opposed to one character at a time, which would be L is written, I is written, T is written, T is written, L is written, E is written, space is written, M is written. So it's writing that line at a time. Yes? Yep.
Mm-hmm.
Okay. Right. Now, so S is going to be put equal to each one of those lines. All right. Now, so I am going to say while S is equal to, now we go buff read dot. So now we've got read, and what we really care about is read line. All right, that's the one we read. Now, read line reads in a line of text. That's what it does. Okay, so just to show, I'll just show you. Okay, so if I go, I'll start here. So if I go buff read dot read line, what'll that print out? Does anyone take a guess? So what we're doing is we're basing it on this file, right? Little Miss Muffet sat on a tuffet. So how will buff read dot read line? What'll that print off?
First line.
First line. Okay. Oops, I'm going on the wrong thing. This is EX1. Okay. Hold on a second now. Why is it reading null? Hold on a minute. Yeah, I'll try that again. Hold on, let me just see. That should read the line. So it's reading null. Okay, let me just try this. Is is the reader that read line is not equal to null. So let me just see. Yes.
Oh, you have to sign it to something, do you? Is that it?
Oh, I hadn't done what S is. Sorry, I haven't done what S is. Yeah, sorry. Goodness. Yeah, you did. Okay. Well, let me just see. No, that should be. Okay, that's not printing out anything. All right. So input.
I want to comment out this is line 44.
Line 44. Oh no, I do want to comment that out. Okay. Let me just see. My strings. I'm going to add that to my strings. Okay. So my strings is a list. Let me just see, is there anything in my strings now?
No, it's all right.
No, it's not being added. Okay, so I have done something wrong then. Oh yeah. I have the file in the wrong project. No, I don't. No, I don't. Okay, examples. Man. Oh yeah, I have it in the wrong place. Yeah, I know. Fuck off. Okay. Right. So I had it in the wrong place. Yep. So now it should be okay. Now we go take out this guy. And I put in here. Alex. Okay.
You don't need your S equals.
No.
No?
No. Hold on a second now. So input.txt. There's nothing in it. Oh, good man, no. Right. Well, that's that. So never mind that this text is funny. Okay, so I have Little Miss. No. Okay. I have to make sure it's in the right directory. So now we should be. Okay, yeah. Little Miss Muffet. Okay, we're fine. Now, right. I'll just comment out this guy. So, little buff read line. If I put in another one. So, it operates the exact same way as read. All right. Except one character at a time, this is going to do one line at a time. All right. So, read line will read the first Little Miss Muffet. Then it moves on to the next line. So put in here. So read line returns null when it gets to the end of the file. Okay. Read line reads in a full line. Okay. Or nursery line reads in the full line and goes to the next line. So this will read Little Miss Muffet sat on a tuffet. Okay. Now, so I'm going to go here. So I'm going to comment out these two lines. Because if I didn't come out those two lines, it would start on the third line. The third line being eating her Christmas pie. Okay, we wanted to start on Little Miss Muffet, so it's going to keep on reading lines until it gets to the end of the file. Okay, now rather than putting in two separate. Now, if I have a buffered writer, what I will do is now, tomorrow before we do it, obviously enough. I'm going to create a buffered writer tomorrow, and I'm going to use the buffered writer to write to a new piece of text. Okay? But first of all, what I'm going to do is I'm going to assign each one of the lines of text to these guys. Okay? So my strings is going to be made up of 6 different strings. The first string is going to be Little Miss Muffet. The second string is going to be sat on a tuffet. The third string is going to be eating a Christmas pie. The fourth string is along came the spider. The fifth string is going sat down beside her. The sixth string is going to be and frightened Miss Muffet away. So I'm going to go back to here. So print it out. There it is. Little Miss Muffet sat on a tuffet eating her Christmas pie. Along came a spider and sat down beside her and frightened Miss Muffet away. So we have taken full lines of text and it has added them as to an array of string. The first item is going to be the first line, the second item is going to be the second line, and so on and so forth. Okay, if there was 1,000 lines in this text, it's going to be you're going to have 1,000 entries in your array list. Just like as well, if you had what is called a CSV file. What's a CSV file? A CSV file is a spreadsheet. Okay, it is a spreadsheet and everything is organized in commas. It's comma separated value file, that's what it says. Okay, it's written in kind of like code and it's right, it looks like this. So 10, 12, 23, 45. create another line then of 12, 6, 77, 99. Okay, now that would be a spreadsheet of 2 rows and 4 columns. Okay, so you could interact with a CSV file and take the first column to be an age, the second column to be a weight, the third one to be an age, and the fourth one to be your address. All right. So you can see already, you're starting to interact with files. You're starting to get information from files. All right. Now that's us finished for today. Now, just to mention, Jason, are you there, Jason?
I'm here, yep.
Yeah, the reason I want to ask you is because your brother develops apps, right?
Yep.
Right. So I was at the doctor's Friday, and all health facilities are now operating queues of some description, right? Now the queue they have down there is very inefficient. It goes in the car registration. But you always get someone, some outlet, or someone who comes in some other car, or we were waiting for an hour because they missed our car registration, right? Now, what we want to develop is, we want to develop a virtual app, a queue, an app that allows us to queue virtually. Now, what I mean a virtual queue is when we come to within, let's say, 100 meters of a location, you'll be automatically entered into the queue. And when it's your turn in the queue, a message will be sent to your phone. That's what we want to develop. That's what he was asking me about. And the doctor asked me about it.
Oh, they were actually asked, the doctor itself was actually saying.
Yeah, well, it actually was a nurse. It was the nurse that was there.
Right. Okay, brilliant.
So also now, so the doctor's app you could only join the queue in the doctor's surgery unless you got an invite to join the queue. Do you know what I'm saying?
Right.
Yeah, so that's the doctor's one. Now,
You'd have to request an invite first then, obviously, right?
Well, no. So you'll have to ring. Well, I mean, you're making a doctor, you have to make an appointment anyway.
Oh yeah, okay. He gives you like a code or something.
Yeah. Well, it'll be sent to your app automatically. You're added to the queue automatically then, and then when you come to within 100 meters of the place, you're automatically added to the queue.
Yep.
Right now, also, my sister went to a butcher's the other day, and they have someone at the door only letting in 4 people at a time. You could also develop a more kind of a general virtual queuing app. When you're in 100 meters of a place and there's not 4 people, so if there's 4 people inside the shop, you'll get a message that says, do not enter the shop. Or you could even have it linked up to the lock on the door. The door won't open until there's only 3 people in the shop.
Yeah.
Right? So they come along and they're waiting out in their car, and as soon as there is only 3 people in the shop, the next person in the queue say, you can now enter.
Yeah.
So
okay.
Just what I want you to do is ask you what we need to develop that app. That's all.
The biggest issue I was thinking there, though, with regard to this is what happens for the people who don't even have phones? You know,
right.
the elderly.
Well, here's the thing.
Exactly.
Yeah, right. Now, so first of all, it needs some way as well to be able to interact with more basic phones. Right?
Okay.
Yeah.
So it needs some way to interact with basic phones. Also, if you're dealing with someone who doesn't have a phone, it'll have to operate then on something like their car registration.
Yeah.
Or so then that would require the shopkeeper to look out the window and have a look for the car registration.
Or just even allow them the option to change the ordering themselves manually somehow.
Yeah, well, it has to be. Now, the main thing here, it has to be seamless to use.
Yeah.
All right. In actual fact, it's probably that they wouldn't have an app on their phone at all. Now, the more tech savvy can have the app on their phone, but the more basic people, let's say, if you've got a basic mobile phone, or people who don't, it'll just send them a text message to say, "Come in now."
Yeah, yeah.
So,
Okay.
yes, it does have to be usable under all circumstances. So we have to devise a method that means you don't need a phone even to use it. Now, if you have a phone, obviously it's going to make your life a lot easier. And you could develop this further when the virus is over to queuing for tickets for Ticketmaster or whatever. Anything that involves queuing, this can be used.
Yeah, yeah.
Okay. Now it's all about keeping social distancing as well. So you don't need to actually be there present. As long as you're within 100 meters of the place, you can queue.
Yeah, yeah, yeah.
And it's specifically it was the nurse or the doctors that was asking me about it. So I told her what I did, and she said, Eugene, she said, we're having terrible problems with queuing.
What was the plan then for? Are we making it for Android or what's this?
Android.
What are we thinking?
Well, actually, see, the thing is, you develop it on. I mean, the doctor surgery is going to have the main stuff. The temporary thing can be just a text message to start off with, and then you can develop the app. So if you just get the thing the doctor has, it just sends off a text message. Come in now.
And it's sending to any phone. Yeah. Okay. Yeah.
So yeah, go on.
No, that's grand. I was thinking maybe two at the very start, but maybe that's too much. If somebody rings up,